My name is Ralf Wondratschek, and I'm a software engineer at Square. I just joined Square. Square is hiring, so if you're interested, feel free to reach out. The topic of today is background jobs on Android. And if this talk somehow sounds familiar to you, it might be because I gave a similar one last year at the droidCon in New York City. Back then, I was focusing more on the framework APIs that Android provides, but today we are looking more at the better things that are built on top of that. Something that hasn't changed compared to last year is this little icon that we all try to avoid, and it is still important, and we should really measure the performance of our apps, but also the battery usage. And we should try to avoid it as much as we can. So what are we trying to do? We try to run something in the background, something that has to run. For example, we want to show a notification in the morning, or we want to sync our data. Those tasks are deferrable. They don't need to run at a specific point in time. But on the other side, you have certain requirements, like I don't want to sync my data when I don't have a working network connection. So we have those requirements. And ideally, the operating system tries to batch those jobs so that it can run them together in order to save battery. So how do we get there? Let's go a little bit back in time and understand how Android has evolved over the years, and that helps us to understand how we got here and why we have all those new APIs on top of that. In 2008, when Android released, we started with AlarmManager. Hands up, who has used AlarmManager in the past? Who is still using it? Well, that's good. So the good thing first about AlarmManager is, of course, it was available since version 1, so it's available on all devices. And the API isn't that nice, but it's also not too difficult. You just wrap your intent inside of a pending intent, and then you tell the system, hey, please send this intent in 1 hour, 2 hours, or whatever. And then you can start your service or launch your broadcast receiver. The problem is that the AlarmManager doesn't respect the device state. So you have to manually check when your service starts, whether you have a working network connection or not. And then it was silent for a while, until 2013 when Android KitKat released. And there the behavior of the AlarmManager was changed. And they did this silently, what wasn't that great until now, until KitKat, all your alarms were exact, and suddenly this changed. They added a new API for scheduling exact alarms, but your previous alarms were suddenly inexact. So this wasn't a behavior change you had to be aware of. Then in 2014, Android Lollipop was released, and we had a new API, Job Scheduler. And Job Scheduler is great. It provides a fluent API for your background jobs. It respects the device state. So you can say something like, hey, run this job only while the device is charging. Problem, of course, is it's a platform API. That means it's only available on 21 plus and above. And back then, you couldn't target Android Lollipop as a main SDK version. And then additionally, there are a couple of platform bugs you also have to be aware of. 1 year later, Marshmallow was released, and Marshmallow came with a lot of improvements, and 2 of them were new 2 power-saving modes, one called DOS and the other App Standby. And as a developer, you don't need to understand them in depth, as long as you have this graph in mind. It basically says, hey, device is currently active, and after a while it's not being used anymore, it goes into this DOS mode, where no application is allowed to run, and there it really can save a lot of battery. After a while, it goes into this maintenance window. There, the Android OS is looking for tasks it needs to run, and it checks all the apps and runs if the requirements are met. And once the tasks are done, it goes back into the DOS mode and saves battery until the user picks up the device and does something with it. In the same year with Marshmallow, the AlarmManager was changed again. The exact alarms weren't exact anymore because they didn't run when the device was in DOS mode. So we got another API for that, and silently under the hood, they changed the behavior of the existing APIs again. So again, something you need to be aware of. Also in the same year, Google released the GCM Network Manager. And that's also a really great API because it's very similar to Job Scheduler in one way. And it's part of the Google Play Service SDK, so they were able to backport all the features to API 9. So almost all devices out there. The problem is that it's part of the Play Service SDK. So that means you have to check first if the Play services are available on this device. If not, then you cannot use this framework. And this is a problem, especially for devices from the Chinese market. Often and usually they don't have the Play service. So you have to implement a fallback. Same year at my former company, I was facing the same challenges. I had all those APIs, they were different. I couldn't combine them or reuse them. I had to implement fallback mechanisms. So I came up with this library called Android Job, and it basically provides a single API which is using under the hood the AlarmManager, Job Scheduler, and GCM Network Manager. And in this library, I backported many features, and we will talk later on more about it. The following year, Google released another library, the Job Dispatcher, and the Job Dispatcher had the same idea like Android Job. It was meant as a wrapper around the existing APIs, and it used for that the existing Job Scheduler API, so it looks identical to Job Scheduler. The problem was that under the hood, it only used the GCM Network Manager. So again, you had the same constraints, like if the Play services aren't available, then you cannot use the Job Dispatcher either. In 2017, Android Oreo was released, and this was another major release for performance, for battery improvements. Google introduced new background service limitations where they said, if your app is currently in the background, you're not allowed to launch a background service. Otherwise, the app will crash. Then they also added, or actually removed, broadcasts. So remember, back in the days, we had all those broadcast receivers in our manifest to get notifications when the network changes. All of them aren't working anymore. And instead, you should use Job Scheduler and define your requirements there. Same year, they released the Job Intent service. Job Intent service is a replacement for the old Intent service. And the good thing is that it respects the device state. So you can say, hey, start my background Job Intent service, even though my app is currently in the background. And then it defers the task for you when you're not allowed to run the service. But it isn't really a job scheduling engine in the same way like Job Scheduler or GCM Network Manager. It's really just meant for running tasks immediately. Then, this year, Google announced during the Google I/O WorkManager as a new architecture component, and it comes with a similar promise that it's a single API around the other ones like AlarmManager and Job Scheduler. And yeah, like I said, it's part of the architecture component, so Google can update it on the fly, and you can upgrade the newer versions. And we will talk about WorkManager in a minute. So that was a lot. We had AlarmManager, Job Scheduler, and many others. And the obvious question is now, of course, which one should you use for your app? And the famous answer is, it depends. In the short term, I would probably recommend using Android Job because it's out there for such a long time. And many companies are using it, like Square is using it, Twitter is using it, and many more. But in the long term, I definitely recommend migrating to WorkManager because WorkManager is the future. Google is supporting it. They are fixing issues there. They are fixing platform bugs in the existing framework APIs. So you really should use that. I try to explain how I came to this conclusion. Like I said, Android Job and WorkManager, they sit on top, and they are a wrapper around the other APIs and use them under the hood. So internally, they're using AlarmManager, so you don't have to deal with AlarmManager directly anymore. For example, WorkManager relies on those APIs, and here you see which API is being used, and similar is Android Job. So let's have a quick look at Android Job, how it works, and what it tries to do. Like I said, it's a wrapper around the existing APIs, and I backported many of the features that newer versions have, like Job Scheduler was released in Lollipop, but later it got more features and more capabilities, and I've backported them to older releases. And internally, it automatically chooses the best API for you, depending on your requirements, depending on your device and its state. And then of course, on top of that, there are many, many more features. So the setup is straightforward. You just add a dependency. Then you have to do a little bit of wiring where you create the job manager and you add this job creator interface, what we see here in a second. This is really just an interface that maps a specific tag to your job instance. So later when you schedule a job, you specify the tag, and here you create the concrete job instance. And here we actually see a job. This is straightforward. You just need to extend the job class, and then you have to override one method where you do all your work and then return a result. That's about it. More interesting is how you schedule a job. First things first, you need to have a tag. That's what we've seen before in the job creator interface. Then you create a builder object. You specify your constraints and give it some input data, and then you just build it and call schedule, and then you're done, and it's working. So you don't have to deal with job scheduler anymore. You don't have to register any broadcast receivers or servers in your manifest. That's enough. Let's compare this with WorkManager. WorkManager, as mentioned before, is a wrapper around the existing APIs. Many features were backported to API 14. It automatically chooses the best API for your requirements, and on top of this, it has many more features. This somehow sounds familiar to Android Job. They really tried to tackle the same problem. The setup is also really similar. You just add a dependency. If you're using Kotlin, I highly recommend using the KTX library. And if you want to write tests, they have an additional testing library. Probably you want to add all three of them. Then implementing a worker is also really simple. You just need to extend the worker class. One of the recent changes was that they added those constructor parameters. You just need to add them. It's nothing fancy. It's straightforward, but only something to be aware of. Then same thing again here. You override one method, and you return your result once your work is done. And same thing here. That's really similar to Android Job. It's just another constructor call, and the method name is a little different. Again, same thing here. How do we schedule a worker in the system? First, you create your builder object. You add a tag to it. This isn't mandatory, but I would recommend adding a tag so that you can later find a specific worker for a tag, so it helps you to identify your workers. Then you give it some input data, and then you just call build and then queue, and that's it. And same thing here. This is really similar to Android Job. But instead of focusing on the similarities, let's have a look what the differences are. And I showed this slide 2 months ago at a droidCon in New York City, and WorkManager wasn't doing that great yet, but into those 2 months, things really have changed, and WorkManager is way better now and suited for the future. So let's run through all those things that Android Job provides and that WorkManager provides. Let's start with exact jobs. Exact jobs are things like, hey, I want to show a reminder notification at 8 in the morning. So you have really this time requirement. And with Android Job, this is straightforward to do. You just say set exact and give it a time. That's about it. WorkManager doesn't have this feature, and they probably also won't add it. The reason for this is, if you think about our requirements or what we're trying to solve, we try to improve the battery life of our application. And exact alarms defeat this purpose. If the device is currently in a doze mode, then you shouldn't wake it up unnecessarily. And exact jobs wake up the device. So this is really battery intensive, and you should avoid it if possible. Then another thing that Android Job has are daily jobs. Things like, hey, run a certain task once a day at a specific time window, and repeat this over and over again every day. And implementing this is straightforward. There's a specific class for that. Other things are similar. The schedule method is also not that difficult. First, I'm checking if already one of the daily jobs is scheduled. If yes, then I don't need to schedule a second one. So I stop here. Otherwise, I create my builder object, and then I schedule the job in the system with a time window, in this case, between 5 a.m. and 8 a.m. in the morning. Transient jobs are coming from the job scheduler that was added, I think, in API 24 or something like that. You don't need to use it that often. They don't really have a good use case, in my opinion, because you want to schedule a job if you really need to do something in the future, even if your application terminates. And transient jobs go away. Once your process dies, the job is gone and it won't run. But nonetheless, I've backported the feature so you can use it in Android job. And the benefit of them is that you can pass in a read bundle as an argument. Before that, we had this persistable bundle with only primitive types like integers and strings. Here, you can reuse a read bundle and pass in parser bits, for example. Android job doesn't rely on reflection, whereas WorkManager does. It's not really a big deal, but only something to be aware of. The library automatically comes with this progot configuration, and it has this rule that it says, hey, don't obfuscate all the workers. So if you use obfuscation and you're wondering why your worker class names don't change, then it's because of that. And the problem here is these rules come automatically with the library, and the Android Gradle plugin doesn't provide a way to turn these off, so you have to live with them. If you want to add a custom logger, for example, if you want to send all the messages into your own log or write them to a file, you can do this with Android job. Just add this logger interface. WorkManager doesn't have this feature. You only can specify a logging level, but also then WorkManager is only sending the messages to Logcat. So if you want to integrate this with your own logging system, that's not working, unfortunately. All right, those are the things that Android job has. What they have in common is that they both support dependency injection. And this is a new change, and I think it was added in WorkManager in the last 2 months. So if you remember, we had this job creator interface in Android job, and this basically opens the door for dependency injection, because here you can manually create your jobs. And WorkManager now has exactly the same interface called Worker Factory, where you get this worker class name in the method, and then you return your worker instance. So this opens the door for us, and I quickly want to run through how you can use Dagger, for example, for this. There are many samples out there how you do this with Android job, but I didn't find one with Dagger, so I will cover this. Imagine we have our sample worker where we have the necessary constructor parameters of context and worker parameters that we then pass to the superclass here. But then we have this third parameter, our API. Who knows where this is coming from, but we want to use this in our worker. So Dagger knows how to provide this, so we want to inject this. Then Dagger has this awesome feature. You just annotate a constructor, and then it knows how to create a worker for you. So how do we get from here and the worker factory to our site that we can actually use Dagger? And imagine this is just this API, this module that we somewhere have in our object graph, and it provides the API. So Dagger knows how to provide this. If we go back to the worker factory that WorkManager provides, we get our application context and the worker parameters from this method. So Dagger doesn't know where those things are coming from. We have to teach Dagger how to provide them in our object graph. And the best thing to do this, and how I would do this, is through a separate module where you pass in the parameters in the constructor, and then you tell Dagger, hey, please provide them when someone requests them. Then you can create your component. This looks a little bit scary, but it's really straightforward. It's a subcomponent. I use my module that I've just shown you before here so that Dagger knows, hey, I get the worker parameters from there. Then I create a builder object. Dagger doesn't know how to create a worker module, so I manually need to pass this in. And then I'm done with the module. The other thing that I've added is a factory method. So Dagger can now inject the sample Dagger worker and knows how to create it. This is basically a factory method that I will use later. And then I just, in my application component, I teach Dagger how it can start creating my worker component. All right, now back to our worker factory, which is coming from WorkManager. There, I'm passing the application component as an argument so that they can create my subcomponent. So when my method is called, I check the class name. If it matches my specific worker, then I use my application component to create my subcomponent. And here I also create my worker module that I've shown you before. And that tells Dagger, hey, I can provide now the worker parameters for you. And then I call my factory method, which creates my own worker for me, and I return this. In order to use a worker factory with WorkManager, you have to manually set this up. And the best place to do this is in your application class, probably. That's what I'm doing here. I create my application component. Then I create my own worker factory where I pass in my Dagger application component. And then I just call initialize. The other thing that I haven't taught you yet is WorkManager is a singleton, so you're only allowed to call initialize once. Since we want to manually initialize WorkManager, we have to remove this content provider, and that automatically comes with the library. What would instead initialize WorkManager with the default values? And this provider is called before your code, so you have to manually turn it off. But after that, we are done. We can Dagger is set up, we can inject workers, and I know what you think, that's a lot of boilerplate code, but the reality is that you write those classes, the subcomponent, the modules, you write them only once. After that, you just create your workers and annotate them with inject, and it works. There's also a lot of room for improvement. For example, you could this worker factory, you could use Dagger multi-binding, so you could really remove the boilerplate there and improve this if you want. So it's even less code. Now let's switch to the features that WorkManager has and Android Job doesn't provide. One of the cool things is that you can chain workers in WorkManager. Imagine we have a photo application where we want to compress images and then upload them to our service. If we have multiple photos, then we can compress them in parallel and then batch them together and run this upload task for all the images. And that's really easy to do with WorkManager. The interesting part here is that you get the image in your compress worker. Then once you're done with compressing the worker, you pass or set this output data. So workers not only can have input data, but they can actually have also output data. Then we switch to our upload worker, which runs after that. And here we get the previous output data from the previous workers as input data. In this case, it's an array. And then I have all my compressed images, and I can upload them. How do you schedule something like this or enqueue the workers in the system? It's straightforward. You have the image data as array as your input. And then for each image, I'm creating my work request. After this, I create this single upload worker. And here I say, use the array creating input merger. You can specify your own input merger. The library comes with 2 defaults, and probably most of the time you want to use the array creating input merger, where each output is combined into one single array. And then after that, you just say, hey, WorkManager, please begin this task with compressing all those work requests. With those compressed work requests. After this, run my upload worker, and that's it. You're done. Then WorkManager figures out the rest. Testing is also something that changed in the last 2 months. Before that, it was impossible to unit test your workers. And now, fortunately, it's working. So in my sample here, I can do this. I create my fake input data. And after this, I can create my upload worker. I pass in my fake data in the constructor with the context and the worker parameters. And then I just call do work, where I get a result back. And I can make assertions about the result. This was something that didn't work before, so I'm happy that they changed the API for that. Unit testing in Android Job also works. It isn't that great like WorkManager, so WorkManager is better suited for that, but it works. I want to show you nonetheless. Same thing. You create your input data. In this case, I have a couple of mocks. Then I create my upload job, and I call on run job with my fake data. And the trick here is that I had to the workaround actually is that I had to make on run job public because initially it's only a protected method. But in order to call it from my test, I have to make it public. And then I get the result back and can make assertions. The other cool thing about WorkManager is that you can also unit test your workers. So you run your tests on a real Android device in the real environment and then can make sure that everything is working correctly. So I had to change my schedule method for this a little bit. So each time you create a work request, WorkManager creates a specific UUID, a unique identifier for your worker. And we can use this in our test to make those assertions and find our worker. So how does this look like in the instrumentation test? First thing you have to do, you have to initialize WorkManager with this test WorkManager. This custom WorkManager allows you to override constraints. For example, if you want to run your worker in 1 hour, then you can override this time constraint so that you don't have to wait a full hour. Then I create my real data here and call schedule on my upload worker. And the key to understand is here, when I call schedule and call in queue, the test WorkManager immediately runs your worker. It doesn't wait. So when this method returns and gives me back the unique ID, then my worker finished already. And I can use this information to get the information about my worker, and there I can verify the result. Sometimes you also want to observe changes. For example, you have a longer running worker and you want to display a notification or some other UI in your app, then you want to observe the life cycle of your workers. That's something Android Job doesn't provide. You can query the status, but there's no API for registering a callback. WorkManager has that, and that's pretty cool. So you can call this getWorkInfo method. You can either let it return a live data object, so that's helpful for the UI side, or you can return a listenable future. That's a Guava type we will talk about in a second. And there you can call the plugin get method to get your result or your state. One feature that I like most about WorkManager is that it comes with its own job scheduling engine. This is a screenshot of the issues inside of Android Job, and they have a common theme where people say, hey, I scheduled a job, it's running 2-3 times, but then it stops working. Why is this happening? And I don't have a clear answer to this because Android Job internally relies on the platform APIs, and they sometimes fail because they have bugs. And Google is aware of those issues, so they implemented workarounds inside of WorkManager, so they could fix this. But other than that, WorkManager also has its own job scheduling engine where it manually checks your workers and their constraints. And if the constraints are all met, then it manually launches your workers. And it doesn't necessarily need to rely on Job Scheduler or AlarmManager. So they fixed all of those issues. It also comes with an asynchronous API. Imagine we have something like this, and we want to upload an image, and this returns a completable, an ArcsJava type. So it's not really nice to integrate. For example, if you think of Android Job, there's only one way because it's a synchronous API. You have to call plugin get. And that's not great. This will lead to bugs and probably also deadlocks. So hopefully you don't need to do this. WorkManager has a solution for that, and this is called listenable worker. Until now, I've only shown you the worker class and told you, hey, you have to extend worker. But the truth is, worker actually extends listenable worker. And listenable worker is the asynchronous API. And the worker class just uses this asynchronous API in a blocking fashion. So how can you implement this? It's a lot of code. Don't be scared. It's not that difficult. The first difference is that you extend listenable worker, the new asynchronous API. Then you write the start work method, what returns a listenable future and not a concrete result yet. Oh, and by the way, listenable future, that's the Guava type. And you shouldn't be scared now that you pull in the whole Guava library. They extracted this interface into a separate library, which is then also used by Guava. So you don't pull in Guava. Don't be scared about this. That's just a common API they want to rely on more and more. Then I create my feature. This resolvable feature is coming from a new Android X library. I think it's called concurrent feature. They didn't speak that much about it yet, but this is basically a helper that implements the listenable feature interface, and yeah, it's easier to use than the interface itself. So, and then I check my input data once I've created all of these, and if I don't get valid input data, then I set a result as a failure and return the feature immediately, and I don't need to do any work. If I got a valid input data, then I call my API to upload the image, and with ArcsJava, this returns a disposable. I save this disposable for later so that I can stop the work early. In my callbacks, if I get a result, I just tell WorkManager basically in the future, hey, this is successful. I'm done with my work. Or if there was an error, then I can say, hey, that's an exception, something unpredicted happened. And like I said, you can stop your work early, and it's highly recommended to override this method if you use this API. It's not necessary, but also straightforward to do, and be a good citizen, override this API. And this onStop method is, for example, called when your constraints aren't met anymore. For example, you have this worker that relies on the network connection. If the network connection goes away, then the system sends you a notification, hey, please stop your work. Your constraints aren't met anymore. Scheduling this a worker with this asynchronous API is the same like with the normal workers, so nothing changed there. It's the same thing. I know what you're wondering now. Okay, ArcsJava, that's all. We all should use coroutines now. That's the new hot thing. And fortunately, you don't have to do much work there because the KTX library of WorkManager comes with a coroutine worker, and you can plug in your coroutines there, so that's working. You just need to extend this coroutine worker class, similar API, and you override one method, the doWork method, but in this case, it's a suspend function already, so you can do your work in there. So now I've shown you all those cool features that WorkManager has and Android Job doesn't have, and I know many companies out there are still relying on Android Job, and the question is now, how do you get from Android Job to WorkManager? And the good thing is, you can use both in parallel, actually, and you can tell Android Job to use WorkManager under the hood so that you can later slowly migrate the usage where you use Android Job and then convert it to WorkManager. So use both in parallel. That's my best advice for that. You just need to add the dependency, and that's actually about it. You can optionally set the API enabled, but this is done implicitly. So because WorkManager is so much better with scheduling with the work, Android Job automatically checks your class path, and if it finds WorkManager, then it's using it under the hood automatically. So but with this way, you can also turn this off if you don't want to have this behavior. But how can you really remove Android Job? So if you really want to migrate to WorkManager, yeah, of course you have to remove Android Job from your dependencies. And then my advice for your recurring work is to schedule new workers like on a new application install. So if you have something like a sync job that you run every 6 hours or something like that, on a fresh application install, you would check, hey, is this periodic worker already scheduled? If yes, then do nothing, otherwise schedule this periodic worker. And you do the same thing when you remove Android Job. With your new workers, you just check this condition. In the worst case, if you really want to copy data over from Android Job to WorkManager, Android Job uses this database internally, and it's still around. There you find all the information that it stores, and you can query this database manually and then copy things if you need to. Okay, now it's almost time for questions, and I have some for myself. One of the obvious things is now, WorkManager is great. Should you now replace all your async tasks, executors, ArcsJava with WorkManager? And the answer is no. WorkManager is really meant for background tasks that really needs to happen, that we really need to do. For example, if you load an image just to display it in your UI from your disk, then you don't need to use WorkManager for that. If your UI goes away, then you want to stop your work, and WorkManager isn't really built for that. So please still use the existing APIs, maybe besides async task. Can you use WorkManager although it's still in alpha release? I cannot tell you what you should do and what you shouldn't do. Google changed the API a lot recently, and that's good because WorkManager had those issues and they fixed them, and I'm happy about it. And I would hope that they would still fix some other issues, like it's a little weird with this thing in the test. This is all awkward. I really would hope they would change that. But other than that, they said by now the APIs should be stable and they don't plan to do any major change anymore. So you could use WorkManager. It's working. If there are any bugs, please file them. I bet Google would be happy about any bug reports. So yeah, go for it. Android job will be deprecated at some point in time. What should you do? Yes, that's true. I would recommend migrating to WorkManager, and because that's the future. But only because a library is deprecated doesn't mean it stops working. So you can still use it. It's working. It's proven. It's out there. But WorkManager just is better suited for the future. What about the features that Android job that WorkManager doesn't have? Yeah, I don't have a real answer for you. You can keep using Android job for that, or you implement them manually with AlarmManager, for example, in the case of exec jobs. So what about Android X? Both libraries are currently still using the support library and didn't migrate to Android X yet. This isn't a problem for you as a user of any of these libraries. If you are still using the support libraries, you're good. If you already migrated to Android X, then Chedifier has you covered and transforms the bytecode for you. But then again, the support libraries are old. Android X is the new thing, and Google, of course, should be a good sample and use them internally. And they plan to add Android X to WorkManager for the 1.0 release. But currently in its alpha state, it's still using the support library. The change will come at some point in time. So if you wait for 1.0 for WorkManager, then you should migrate your code yourself to Android X. All right, that's all I have. Thank you very much. Are there any questions? Could you please go to the microphone, or otherwise I repeat the question.
So I was curious about other triggers for WorkManager. So in this instance, I was worried about whether or not we could trigger events from hardware-related activities, such as whenever the Bluetooth radio is active instead of just on, or Wi-Fi, same thing right there.
There's no easy solution to this. Probably the best thing to do is to register your broadcast receiver yourself, and then when the broadcast receiver is called, then you have to create your worker and launch it immediately. WorkManager comes only with a subset of constraints, and those are mainly implemented in Job Scheduler. So as long as Job Scheduler doesn't implement them, WorkManager probably won't have them either. So you have to do this yourself, unfortunately. Okay. Otherwise, I'm around. Reach out to me and enjoy the rest of the conference. Thank you.